The closest star to our solar system, besides the Sun, is Proxima Centauri, sitting about 4 light-years away. But here's something that might surprise you. You've almost certainly never seen it. Not because it's hiding behind clouds, and not because you've never looked up at the right moment, but because from the northern hemisphere, it's simply not visible. So that raises a question. What is the closest star to us in the northern sky? The answer is Barnard's star. And despite being just 6 light-years away, the odds that you've ever spotted it with the naked eye are essentially 0. Why? Let's get into it. Red dwarfs are the most common type of star you can find in any galaxy. In our own Milky Way, they make up a staggering 60 to 70% of all stars. In astronomy, if a star has a mass roughly 60% that of the Sun or less, we classify it as a red dwarf. These are genuinely low-mass stars, and because of that low mass, they burn through their fuel far more slowly and steadily than other types of stars. As a result, a red dwarf doesn't radiate light at anywhere near the intensity of, say, a red giant. Their surface temperatures can't even exceed around 3,600 degrees Celsius, and they emit only about 1,000th of the energy our Sun puts out. Low mass, low luminosity, low temperature. On the surface, red dwarfs don't seem all that impressive. But there's one area where they outperform every other type of star: longevity. Because they burn their fuel so slowly, red dwarfs live extraordinarily long lives. So long, in fact, that compared to our own lifespans, they might as well live forever. Astronomy has its own version of the live fast, die young principle. The more massive a star is, the faster it burns through the elements in its core, and the sooner it dies. A typical red dwarf, by contrast, can live anywhere from 70 billion to trillions of years. To put that in perspective, our Sun, which is considered a relatively low-mass star in its own right, has a lifespan of around 10 billion years. And when you consider that the entire universe is only about 13 billion years old, the sheer scale of a red dwarf's lifespan starts to sink in. Barnard's star is exactly that: a red dwarf. It sits in the constellation Ophiuchus at a distance of precisely 5.9 light-years from us. Yet despite this proximity, you won't see it even from the darkest skies on Earth. You need a good pair of binoculars or a telescope to spot it at all, and that's precisely why, as strange as it sounds, the second closest star to our solar system wasn't discovered until the 20th century. The discovery was made by an American astronomer named Edward Emerson Barnard, which, as you might have guessed from the star's name, is exactly who you'd expect. Barnard began working at the Lick Observatory in 1888, and, using its equipment, managed to discover 18 comets. His extraordinary attention to detail made him one of the most talented observational astronomers of his era, and he was also a skilled astrophotographer, someone who had combined his love of astronomy with photography from the age of just 9. At the Lick Observatory, he took more than 4,000 photographs of the Milky Way. While examining photos taken between 1894 and 1916, Barnard noticed something unusual in the constellation Ophiuchus: a faint star with a remarkably peculiar property. Compared to the background stars, it was moving fast. So fast, in fact, that its rate of displacement across the sky meant it could shift the apparent width of a full moon across the sky in just 180 years. For a star, that's an extraordinary speed, and it's a clear indicator that the object is very close to us. You can actually demonstrate why with a simple experiment right now. Close one eye and hold your index finger up at nose level. Now open the closed eye and shut the other one. Your finger appears to jump to the side. The closer your finger is to your face, the more it seems to shift. That's parallax. And the same principle explains why Barnard's star moves so noticeably across the sky. In 1916, the star was formally identified and its distance was calculated, just 5.94 light-years away. Because of its ideal position in the sky and its proximity to us, Barnard's star has become one of the most studied red dwarfs in history. We know a great deal about its structure and properties. Studies suggest it's between 7 and 12 billion years old, significantly older than our 4.5 billion-year-old Sun, and potentially one of the oldest stars in the entire Milky Way. But don't let the word old mislead you. Because it's a red dwarf, even at 10 billion years of age, Barnard's star is still in its infancy as stars go. It will continue shining for at least another 500 billion years, and possibly trillions. Compared to that timescale, our Sun's entire 10 billion-year lifespan is barely a blink. Normally, the movement of stars across the sky is completely imperceptible within a human lifetime. A star you observed at age 10 will appear to sit in exactly the same spot in the same constellation when you look at it again at 90. Barnard's star is different. It moves 10.3 arc-seconds per year, which means over the course of a single human lifetime, it shifts about 1/4 of a degree across the sky, roughly half the apparent diameter of a full moon. That's genuinely remarkable. And it's getting closer. Its blue shift indicates that in approximately 10,000 years, Barnard's star will have closed to within 3.75 light-years of us. Closer than Proxima Centauri, which currently sits at 4.24 light-years. That said, don't read too much into that. It won't actually claim the title of closest star, because Proxima Centauri will also have shifted its position by then, keeping Barnard's star in second place. And even at that reduced distance, 10,000 years from now, it will still be far too faint to see with the naked eye, a testament to just how dim red dwarfs truly are. Barnard's star has a mass only 16% that of the Sun, a diameter about 19% of the Sun's, and a surface temperature of roughly 2,900 degrees Celsius. Smaller, cooler, and far less massive than our Sun in every measurable way. Given all of that, you'd expect it to be a quiet, uneventful star. But astronomers have observed its surface temperature spiking to around 8,000 degrees Celsius at times, strong evidence that the star experiences massive flare events. Could a star this small and relatively cool host planets? We almost never discover exoplanets by simply pointing a telescope at a star and watching for them directly. Instead, we detect them either by observing the dimming of a star's light as a planet passes in front of it, or by tracking subtle changes in the star's own motion. The low mass of red dwarfs actually makes the second method particularly interesting. Because the star has so little mass, any planet orbiting it can exert a gravitational pull significant enough to make the star wobble slightly. That wobble, even without ever seeing the planet itself, tells us something is there. And because mass is the key parameter in that method, we can even estimate the planet's mass from the data. Based on observations of Barnard's star's motion, astronomers had suspected since 1963 that a Jupiter mass planet might be orbiting it. But that presence couldn't be confirmed. A 2021 study on the topic was ultimately rejected. Then, in August 2024, observations made with the Very Large Telescope, one of the largest telescopes in the world, located in Chile's Atacama Desert, confirmed the existence of a planet with a mass equivalent to just 0.37 times that of Earth. After decades of speculation, the existence of an exoplanet around Barnard's star had been confirmed for the first time. The planet, named Barnard B, completes one full orbit around its star in just 3.15 days. Given that Earth takes 365 days to orbit the Sun, that's a staggeringly short year, though it doesn't mean the planet itself is moving at extreme speed. The low mass of red dwarfs allows planets to orbit at very close distances, and Barnard B is 20 times closer to its star than Mercury is to the Sun. Even so, its surface temperature sits at around 125 degrees Celsius, warm enough that it falls inside the inner edge of what we'd consider the habitable zone, meaning it's too hot to hold liquid water on its surface. Beyond Barnard B, observations suggest the presence of 3 additional exoplanets in the system, tentatively designated Barnard C, D, and E. Their existence hasn't been confirmed the way Barnard B's has, and even if they do exist, they're most likely located even deeper inside the habitable zone's inner boundary, making the prospect of life or habitability on any of them quite remote. Still, consider the bigger picture for a moment. The closest star to us, Proxima Centauri, has one confirmed exoplanet and potentially 2 more for a total of 3. The second closest, Barnard's star, has 1 confirmed exoplanet and potentially 3 more for a total of 4. That's 7 exoplanets across just the 2 nearest stars to our solar system. Now, look up at the night sky and think about how many more stars are out there. Are we alone in the universe? I don't know. But with every new discovery, the possibilities become a little more extraordinary. We'll continue exploring the stars closest to us in the next videos. Until then, take care.